Hello and welcome to your lecture on Learning Outcome 7 and Learning Outcome 8. In this lecture, your objectives are to order, add, subtract and compare amounts or quantities using proper and improper fractions and mixed numbers, as well as being able to express one number as a fraction of another. Okay, so let's get started then. So we're going to start by looking at equivalent fractions and simplest form. A fraction is part of a whole number. So the top number is called the numerator and the bottom number is called the denominator. In a proper fraction, such as 2/5, the denominator is greater than the numerator. So the denominator, the number on the bottom, is always bigger than the numerator, the number on the top. In an improper fraction, such as 15/7, the numerator is greater than the denominator. So the number on the top is bigger than the number on the bottom. It's called an improper fraction because we wouldn't really want to write it like that. Now, a mixed number has a whole number part and a fraction part. For example, 1 and 4/9. This happens when we take an improper fraction like this one, okay, and we say how many whole ones there are and how many parts there are left. Now, if I was to look at 15/7, a whole one is how many 7s go in. So I know that 7 is a whole one. 14 is 2 whole ones because 2 7s are 14. So in this fraction here, I've got 2 whole ones, which makes 14, but I've actually got 15 on top, which means I've got 1 left over out of 7. And it's the number on the bottom that always ends up on the bottom here too. We'll go through that in a little bit more detail in a minute. So just another example of a mixed number is 1 and 4/9. Okay. Now then, equivalent fractions have the same value, so that means that they are basically the same, and you can calculate equivalent fractions by either multiplying or dividing both the numerator and the denominator by the same number. So this box or this drawing shows that I've got one part here coloured in out of 3. Okay, one part's orange out of a total of 1, 2, 3. So we write that as a third. An equivalent fraction to a third would be if I decided to multiply the top and the bottom numbers by 2. Okay, you could multiply them by anything, but I'm just giving you an example of an equivalent fraction. So 1 times 2 is 2 and 3 times 2 is 6. So I could say to you that 1/3 is exactly the same as 2/6. Now here I've drawn the same diagram, but instead I've split the whole piece up into 6. And 2 of them are coloured in orange out of 6 pieces. Okay, and in order to get an equivalent fraction for that one, instead of multiplying, I could divide by 2. And if I divided by 2, it would tell me it would be a third. Okay, so they're the same. As you can see, they're the same size drawing. They've just been split up into more pieces, more equal pieces. Okay, work out the value of x in these pairs of equivalent fractions. So just have a go at working out what x might be using the example that I've just shown you. So you can multiply or divide by a certain number. What number has been used here, and use it to find x. And then press play for the answer. Okay, if you've had a go at that. Now here what you would do for A is you would think, what did I multiply 7 by to get 35? Well, 7 times 5 is 35. So you would do the same to the top number, 5 times 5. Okay, so 7 times 5 is 35, so 5 times 5 is 25. So your equivalent fraction would be 25 over 35. Okay, so moving on to B, you've got to think, what did I do to 50 to get 5? So this time you're going smaller rather than bigger. Whereas with A, you went from 7 to 35, which meant we had to times. So for B, we're going from 50 to 5. So we're going to divide. What did we divide by to get 5? Well, 50 divided by 10 is 5. So 40 divided by 10 is 4. So your answer would be 4 over 5. Okay, so fractions can be simplified if the numerator and the denominator have the same factor, as you've noticed, either through multiplication or division. Fractions can be written in their lowest terms by dividing the numerator and denominator by the highest common factor, okay? So basically, as we've just done on the previous page, you can either multiply by a number to get an equivalent fraction, or you can divide, but it has to be the same number on the top and on the bottom. So, have a go at this one. How would we get this to its simplest form? And this one, and then press play for the answer. Okay. If you've had a go at that, let's go through it. So 12 over 15. What can I do to 12 and 15 to get to the smallest equivalent fraction that it could be? Because this is a common question in the exam. All right, so your answer should have been 4/5. And what you should have done was divided by 3. Because 15 and 12 can both be divided by 3. 12 divided by 3 is 4. And 15 divided by 3 is 5. And then for the next one, you should have got 4 over 6. And that's because we've divided by 6. Okay, 24 divided by 6 is 4. And 36 divided by 6 is 6. Okay, so what we're going to do now is we're going to look at comparing and ordering fractions. Now, in order to compare or order fractions, you first need to convert the fractions to equivalent fractions with a common denominator, okay? So the lowest common multiple of the denominator, the bottom number, is the lowest common denominator of the fractions. So if we look at an example, write the fractions 7/8, 4/5, and 11/20 in order, starting with the smallest. Well, what we need to do is we need to look at those fractions and we need to think about what number all of these go into, okay? So, really, I've got to think about 8, 5 and 20. What number will all of those go into, okay? So, yes, we know that 5s go into 20, but 8s don't go into 20, so we can't use 20. Now, this is why it's very important to know your multiplication tables, because what I do know is that all of these three numbers will go into 40, okay? So all of these numbers will go into 40. In order to get 8 to 40, I times by 5. In order to get 5 to 40, I times by 8. And in order to get 20 to 40, I times by 2. Okay. So, if we start by looking at 7/8, an equivalent fraction to 7/8 is 35 over 40. And the reason for that is because I've done 8 times 5 to get to 40, and I need to have 40 on the bottom, okay, because that's our lowest common denominator. So that means I would have to times that number by 5 as well, giving me 35 on the top, okay. Now if we go to 4/5, my equivalent fraction to 4/5 is 32 over 40. Because I needed 40 on the bottom, I did 5 times 8 to get 40, so I had to do 4 times 8 to get 32 on the top. And then finally, 11 over 20, my equivalent fraction to 11 over 20 is 22 over 40, because in order to get 40, I had to times that by 2, so 20 times 2 is 40, so 11 times 2 is 22. Now from there, we can now see which fractions are the biggest or the smallest. Because what these mean is this 35 out of 40 here. This, if we think about it like in slices of pizza, that's saying that you've got 35 slices left out of a total of what would have been 40. This is saying you've got 32 slices left, and this is saying you've got 22 slices left. And it wanted us to write the fractions in order starting with the smallest. So to start with the smallest, okay, this is the smallest because it's the smallest number on top of 40. So 11 over 20 is our smallest fraction, so that would go first in our list. We've then got 32, which is our second smallest. So 4/5, and look at how I'm writing them as the original fractions. I'm not writing them as my equivalent ones that I came up with. Okay, I'm writing down the ones that I was given in the question. And then so our last one must be 7 over 8. And you have written those fractions in order of size, starting with the smallest. Okay, because you found a common denominator. Now then, what I want you to do is pause the video and have a go at doing this one. Think about a common denominator for all three of those numbers on the bottom, and how would you get to there? And press play for the answer. Okay, so let's have a look at this then. Our three numbers on the bottom of each fraction is 6, 12 and 24. And I need to think about a number that all three of those go into. Okay, so looking at those three numbers, what you should have done is 24 would have been your common denominator here. Okay, because 6 times 4 makes 24. 12 times 2 makes 24, and 24 times 1, or you don't really have to do anything for that one, makes 24, okay? So what we need to do is, we need to look at each of our fractions and we need to turn them into equivalents. So if we look at 4 over 6, my equivalent fraction for 4 over 6 is 16 over 24, because I would have had to multiply this by 4 to get 24, which means I would have had to multiply 4 by 4 to get 16. Okay, remember you must multiply the same number on the top and on the bottom. 3/12 would turn into 6 over 24, because I would have had to do 12 times 2 to give me 24, and 3 times 2 is 6. And 9 over 24 would just stay the same, because I've not actually had to do anything other than maybe times by 1 if you like. Okay, but you didn't have to do that. So now we're saying, okay, here I've got 16 slices out of 24. Here I've got 6 slices out of 24. And here I've got 9 slices. So we know that this is our smallest fraction because it's 6 slices left. That's the smallest one. So our first fraction would be 3/12 because I'm using the same fraction that was in the question. The next one is 9 over 24. And finally, 4/6, because that was actually 16 out of 24. Okay, so if you got that right, well done, very good work. Okay, so now you know how to find equivalent fractions and you know how to compare and order fractions. Let's move on to calculating with fractions and finding some fractions of amounts. So fractions of quantities. To find a fraction of a quantity, you multiply the fraction by the quantity. Sounds a little bit confusing, but I'll show you an example. So, in a survey of 24 college students, okay, so in total there are 24 students, 3/8 prefer the Reading Festival. 3/8 prefer Reading. 1/6 prefer this NASS festival. Don't know what that is. Sorry if I'm getting it wrong. And the remainder prefer Glastonbury. How many students prefer Glastonbury? Okay. So what you've got to do there is you've got to work out the actual number of people that prefer Reading and the actual number of people that prefer this NAS thing. Okay? Now, in total, you've got 24 students. And it says that 3/8 of those students, 3/8 of 24, prefer Reading. Okay, so let's write Reading there so we know. So, when it says 3/8, what that means is it wants you to split that number into 8 pieces, okay, this 24, and then take 3 of those pieces. So 3/8 of 24, you can either think, okay, it's 3/8 times 24, but what does that really mean? And that means we're going to do 24, and we're going to divide by the bottom number, okay, I'm going to write this up here, divide by the bottom, this is the rule when you're working out fractions of amounts, and then times by the top, okay? That's your rule. So 24 divided by 8 is 3, okay? 3/8 of 24. And then because I've now got that answer, I've divided by the bottom, tick, and now I'm going to times by the top number. The top number of my fraction was 3, remember? So I'm going to do 3 times 3, which equals 9. Okay? Okay, next, I've got to look at the NAS festival, or the NASS. It sounds like something from like a film. And it says that 1/6 of the 24 students preferred that festival. Okay? So again, that means like 1/6 times 24. But 1/6 times 24 just means 24 split into 6 pieces. Okay, so divide by the bottom. Sorry, I didn't tick that here when we times by the top, but there we go. 24 divided by the bottom. Okay, 24 divided by 6 is 4. Okay, and then times by the top. Well, if we times by the top number was 1. So really you don't have to do that, but 4 times 1 is 4. So there you go. So 4 people prefer NAS and 9 people prefer Reading. Now it says, how many students prefer Glastonbury? Okay, well, when you have to work that out now, what you're going to do is you're going to say, well, there was a total of 24 students. 9 of them liked Reading, so I'm going to take that away. And 4 of them liked NAS, so I'll take that away. So altogether you're going to do 24, take away 13, because that's 13. Okay, so 24, take away 13 is 11. So 11 students preferred, I mean, you can write this as a sentence if you want. 11 students preferred Glastonbury. And that's it, you've worked it out. Okay? Okay, so what we're going to do now is we're going to move on to a different type of calculation with fractions. And what you're also going to need to be able to do is find a whole from a given fraction. So if we look at this example, it says that a quarter of the length of wood, okay, is 32 centimetres. What is the total length of wood? Okay, total length. So a quarter is 32 centimetres. I want to know if a quarter, which is basically I've split something into 4 pieces, the whole length of it has been split into 4 pieces, and each of those pieces is 32 centimetres. So 4 out of 4 would be the whole one. I need the whole 4. I can't just have 1/4. 1/4 is only 32. I want to know the total length. So if I look at it like this, each piece is 32 centimetres and I've got 4 of them that make a whole one. I know that 4 make a whole one because that's what's on the bottom of my fraction. So that means then all I've got to do is 4 times 32, which gives me 128 centimetres. Okay. And when we split something into fractions, just so you know, we're splitting them up into the same sizes. So if 1/4 is 32, then 2/4 would be 2 lots of 32. 3/4 would be 3 lots of 32. And 4/4, which is the whole one, will be 4 lots of 32. Okay? So it's as simple as that, really. All right. So other than that then, we've also got to work out improper fractions and mixed numbers. Okay, so I hope you're taking a lot of notes here because you're going to need to remember all these things when it comes to those 1 markers in the exam. I mean, sometimes when you're using fractions, you can get up to 4 marks in the exam. Okay, but let's say you got a question like, what's 1/4 of 32, for example, you will get 1 mark for that question. Okay, and you want to be able to get all those little 1 markers because they're really important. That's how you make most of your marks, because when you get to the more difficult sections and you're thinking, oh, I don't know what to do here, you've already gained a good amount at the beginning of the paper. All right, so improper fractions and mixed numbers then. 35/9. Now, this is an improper fraction. 35 is bigger than 9. The number on the top is bigger than the number on the bottom. So it's an improper fraction. Okay, and what we need to do is work out how to turn that into a mixed number. The other example we have is 48/7. and we've got to turn that into a mixed number. So if you think you know how to do this, why don't you pause the video and have a go, and then press play and I'll go through it. Okay, if you've had a go, when we turn an improper fraction into a mixed number, okay, so if we look at this one for a start, 35 over 9, I'm just going to write a few things down over here to help you. So 35 over 9 means that, let's say I've got a pizza, okay, and in each pizza, not that you really get this, and it's going to be really difficult to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I've split that into 9 pieces. Okay, they're not even, but they should be, okay? And what it's saying is that for every 9 slices, I've got a whole one. Okay, one whole. Okay, so how many whole ones can I get out of 35 slices? That's what that means. Okay, so here's 9 pieces. Okay, 9 slices. If I did another one of those, not very well, I'm going to write it like that. That would be 18 pieces or slices. Okay, if I did another one, it would be 27 slices. Okay, so that's 9, 18, 27. So altogether, I can get 3 whole pizzas out of that. Okay, 3 whole pizzas. So all you really need to do is think how many 9s go into 35. Okay. Well, in total, there are 3. 3 whole ones fit into 35. But then we've got some leftovers. We've got some remainders. So we can only fit 3 whole ones, which takes us up to 27. Okay, and then from 27 up to 35, you're left with 8 remainder, 8. And we would say 3 whole ones and 8 remainder out of 9. And that's how you would write that as a mixed number. Okay, all right, we've done that one. Let's have a look at this one now, 48 over 7. It's the bottom number, like I've already said, that tells you how to work it out. Or tells you what number you've got to put into it. Okay, so again, 48 over 7 means that how many 7s go into 48? How many whole pizzas of 7 slices? 1, 2, 3, 5, 6, 7. That was a bit better, wasn't it? 7 slices, okay, equals 1 whole one. I know that because that's what's on the bottom of my fraction. So how many whole pizzas can I fit into 48? Well, I can write down my 7 times table instead of drawing out loads of pizzas. 7, 14, 21, 28, 35, 42, 49. Okay, now, obviously, that's telling me now then how many whole pizzas I can fit in. 1, 2, 3, 4, 5, 6. Okay. I can't fit 7 because I've not got 49 slices, I've only got 48. So I can fit 6 whole ones. And then we just work out how many are left. So 6 whole ones takes us up to 42. Okay, but we need to know what the remainder is because we've actually got 48 slices, as you can see here. So 42 up to 48 is 6. So 42, 43, 44, 45, 46, 47, 48. That's 6. So it's 6 remainder out of 7 because 7 is on the bottom of our fraction here. Okay, and that is our final answer for 48 over 7. So hopefully you've understood that, and in your assignment you'll be able to practice doing those and see how well you do on that. All right, let's move on. Okay, so what we're going to do now is we are going to look at 2 examples of mixed numbers, and we're going to put them back into improper fractions. So we're going to make them so that the top number is bigger than the bottom. All right, this isn't too tricky. So previously, let's say we had 48 over 7 like we did on the previous page. That gave us 6 and 6 out of 7. Now, the reason for that was 7 went into 48 6 times with 6 remainder. Okay, so when we do it this way, what we're doing now is we're saying, okay, well, how many how many slices do I have altogether? So I know from looking at this one here, okay, I mean, if you'd like to pause the video and have a go at this first, please do. If you think you know what you're doing, then fine. All right, if you've done that. So I know that this is saying, okay, I've got one whole one, and one whole one is 9 slices because that's what's on the bottom here. Okay, so one whole one is already 9 slices. So I know I've already got 9. I'm going to write that down. And then I've got 5 left over. So I've got another 5 slices. Okay, so altogether, I've actually got 14 slices. Okay, and to write that as a fraction, I would say, well, it's 14 out of 9 because 9 is what's on the bottom here. And that's it. That's all you've got to do. Now, a better way of looking at that, if I write 1 and 5 over 9 over here, there's a proper method to do this, okay? And all you would do is you would take this whole number, okay, this 1, and you would times it by the bottom, okay, 1 times 9, and then you would add the top. So we'd do 1 times 9 is 9, and then 9 add 5 is 14, okay? And then we'd say, okay, as a fraction, that's 14 out of 9, because 9 is the number of slices in each pizza. All right. So then, to do this one here, all you would do is take the whole number, times it by 7. So 2 times 7 is 14. And then we add the top number. 14 add 4 is 18. So our fraction would be 18 over the bottom number, 7. Okay, that's it. That's all you've got to do in order to turn a mixed number into an improper fraction. Okay, so now we're going to look at adding fractions. Okay, so to add fractions with different denominators, all right, so for example, we could have had 5 over 9 plus 2 over 9, and that's really easy. All we do is 5 add 2, which is 7, and keep the 9 on the bottom the same. Okay, so that's if the denominator is the same. Nice and easy, you just add the top, okay, and keep the bottom the same. If we've got a fraction like this one here, 5 over 9 plus 1 over 7, we need to change the denominator to an equivalent. So we need to change it to an equivalent fraction, and then add the top numbers together. So we need to make it look like this. Now, there are 2 ways you can do that. One way is to think, okay, what number do both 9 and 7 go into? Okay, and you might know that, and you might not. Okay, if you do know that, if you think, okay, what is the lowest common multiple of 9 and 7? All right, you could write out the 9 times table. Okay, and you could write out the 7 times table until you got to a number that was in both. So what I'm going to do is I'm just going to continue doing that now. So I've got 9, 18, 27, 36, 45, 54, 63. And then I'm going to do 28, 35, 42, 49, 56, 60, oh, I can't fit it on, 63. Okay. So what I've done is, here's my 9 times table and here's my 7 times table. And as I can see here, 63 is in both of those times tables. Okay, so this is method 1, all right, where I find the lowest common multiple. So what I'm going to say is that, okay, 63 goes into both of those. So I'm going to write my fractions out again, but this time I'm going to put 63 on the bottom. Okay, 63, 63. And I need to work out, what did I do to this 9 to get to this 63? And if I count 1, 2, 3, 4, 5, 6, 7, I multiply by 7. Okay, that means I'm going to have to multiply 5 by 7, because remember, I have to do the same to the top as I do to the bottom. 5 times 7 is 35. Okay. Now, the next thing I've got to do is I've got to think, how did I get from this 7 to 63? Okay. And if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, I multiplied it by 9. You'll see a pattern in a minute, or a link between the two methods. So I times it by 9. So that means I just need to times this top number by 9. Well, 1 times 9 is 9. Okay, now all I need to do, because my denominators are the same now, I've got 63 on the bottom of both, so 63 would remain the same in my answer, and I would just do 35 add 9, okay, which is 44. Okay, so your answer to 5/9 plus 1/7 is 44 over 63. Okay, and you've done it. Now, I'm going to show you another method, okay, which is called cross multiplication, and you will see a pattern emerge now. Okay, if I put here method 2. So when I do method 2, it's not necessarily shorter, it's fairly long-winded, but it just stops you from having to write out these lists here if you don't know your times tables. Okay, so what I'm going to do is I'm going to write out my fraction again, but this time I'm going to write 9 times 7 on the bottom, because if I look at my fractions over here, I've got 9 and 7 on the bottom of my fractions. I'm going to write 9 times 7 on the bottom. Okay, and then I'm going to put add at the top because it's an addition question. Okay, now I'm just going to do some rubbing out because I don't want to confuse you, so let's just get rid of some of these arrows. All right, sorry about that. Okay, and what I'm going to do now is I'm going to cross multiply. So first of all, I wrote 9 times 7 on the bottom because 9 times 7 is actually going to give us this 63 here. Okay, now this side of my question, I've got 5. Okay, so I'm going to put 5 there, down at the bottom, and I'm going to cross multiply with 7. I'm going to put 5 times 7 there. Okay, and again, that is what is going to give us this 35. And then what I'm going to do is there's 1 on this side of my fraction, 1 times, and I'm going to cross multiply it with the 9. And again, that will give us this 9 here. Okay. So then, all I have to do is write that all out again, but this time, do the actual calculations inside the brackets and at the bottom. So 9 times 7 on the bottom gives us 63, which is what we needed. And then on the top, I've got 5 times 7, which is 35, and 1 times 9, which is 9. And can you see now it's giving us this same thing, except we've just got 63 on the bottom once. We then do 35 plus 9, which is 44, and write it over 63. Okay. Right, so there's 2 methods for adding fractions. I really hope you've understood at least one of those, so you can practice that again using your assignment. Let's have a go at another question. So just pause the video and have a go at this question using one of the methods you've just written down, okay? And then we'll go through the answers. Okay, so let's have a look at this one then. Let's go through both methods again. Let's start with method 1, and we're going to write out our times tables for 5 and 8. Okay, so we're going to find our lowest common multiple of 5 and 8. Okay, so if I write down my 5 times table, 15, 20, 25, 30, 35, 40. Okay, and then 8, 16, 24, 32, 40. Okay, now 40 is our lowest common multiple, so I know that that's going to go on the bottom of both of my fractions. I'm going to put 40 there and then 40 there. Now, what did I do to 5? This is my first fraction. To get 40, I actually times by 8. 1, 2, 3, 4, 5, 6, 7, 8. So that means that the top of my fraction, I need to do 4 times 8. Okay, 4 times 8 is 32, so 32 goes there. Okay, and then I have to look at, I'm just changing my colour. what did I do to this 8 to get 40 here? And I 1, 2, 3, 4 times by 5. Okay, so if I times that by 5, then I need to times this by 5. 3 times 5 is 15. Okay, so then on the bottom of my fraction will be 40. And then on the top of my fraction, I just need to do 32 add 15, which is 47. Okay, so my final answer will be 47 over 40. Okay, now let's have a look at method 2, because just to double check my answer, I guess. So this was method 1, write that there so you don't get confused. Okay, this bit and this bit. Method 2 is my my cross multiply method. Remember, I write my fraction out a bit bigger, and if I just rub out again some of these circles, we have 5 times 8 on the bottom because of those two being there. It's an addition question, so I put add there. And then I've got, again, change my colour real quick, 4 on this side, so I'll put 4 there, times by 8. And then I've got 3 on this side, so 3 goes there, times by, cross multiply with 5. Now, the reason that I'm keeping the 4 on this side of the addition and the 3 on this side, it doesn't necessarily matter with adding, okay? But if you're subtracting, okay, which is exactly the same method, by the way, this would just be a takeaway. And instead of adding them together, you would take them away. All right? When you're subtracting, that really matters, because if you accidentally did it the wrong way round, you would end up with 15 on this side and 32 on this side. And you don't want to be doing 15 take away 32, really, in a fraction. Okay, sometimes you might, but just make sure you put the correct number on the correct side. So if 4 is on this side of the add or the takeaway, it must go on this side. Okay, just there. Sorry, I'm making a mess. Anyway, so going back to this then, we're then going to do 5 times 8 on the bottom, which is 40. Put our add in. 4 times 8 is 32. And 3 times 5 is 15. So again, we just add those together, giving us 47 over 40. And that would be our answer. So I hope you did well on that. Well done if you did. Let's move on. So here's some examples of subtracting fractions then. So again, it's exactly the same method. Okay, so I'm just going to show you the cross multiply method from now on. But if you'd like to have a go, pause the video now and then we'll go through it. Okay, so as I said, I'm just going to use the cross multiply method because it's just a little bit quicker sometimes. So I'm just going to write out my fraction again, but remember with the cross multiply method we're going to use first of all these two bottom numbers, and we're going to do 5 times 3 on the bottom. Now remember this time it's a subtraction, so I would put subtract there. Okay, and then what we're going to do is the same. We're going to cross multiply. 4 is on this side of the subtract, so 4 goes there, and I'm going to cross multiply it with 3 times by 3. And then 1 is on this side, so that goes there, and I cross multiply it with 5. 1 times 5. Okay, so then I am just going to write out my whole fraction again, but this time working out the answers. So 5 times 3 is 15, so that goes on the bottom. And then I have 4 times, don't forget your subtraction in there, 4 times 3 on this side is 12, and 1 times 5 is 5. So 12 take away 5 is 7, and then 15 is on the bottom. And we're done. It's not too bad once you start practicing cross multiplication and adding and subtracting fractions. Okay, let's do one more. So pause the video, have a go, and press play for the answer. Okay, again, just using the cross multiply method now, Writing out my fraction again, 8 times 5 on the bottom, subtract on the top. 7 is on this side of my fraction, so 7 goes there. And I'm going to cross multiply it with 5. And then 2 is on this side, so it goes there. And I cross multiply that with 8. Okay, on the bottom of my fraction, I have 8 times 5, which is 40. And if I put a subtraction in there, I've got 7 times 5 there, which is 35. And 2 times 8 there, which is 16. So just to remind you that knowing your multiplication tables will make this much, much quicker for you. I would definitely spend a bit of time going over them and trying to remember as many as you can. Okay, so 35 take away 16 is 19. 19 over 40, okay? All right, and that's it, you're done. That's your answer. All right. Okay, let's look at multiplying fractions then. Multiplying fractions is not tricky at all, again, as long as you know your multiplication tables. But even if you don't, you can work them out. So let's have a look at multiplying these fractions here. Now, when we multiply fractions, it's quite simple. All you do is we'll go through an example like this, but for example, first of all, if it's like 1 2/3 multiplied by 4/5, okay, you will need to turn this into an improper fraction first. Okay, so the same would go for adding as well. But you should know how to do that because we've gone through it. Remember, we just times 1 times 3, and then we add the 2. So 1 times 3 is 3, 3 plus 2 is 5. So you would end up with 5 over 3 times by 4/5. Okay, so just letting you know that first. Now, once you've got this fraction or this one up the top here, okay, it's really, really easy. All you do is multiply 2 times 4, which is 8, and 5 times 7 is 35. So that would be your answer for that one. And then for this one here, you just do 5 times 4, which is 20, and 3 times 5, which is 15. Okay? Now, so all you're doing is multiplying across. There's no cross multiplication. There's no finding the lowest common denominator. All you've got to do is multiply the top numbers together and the bottom numbers together. Very simple. The only other thing with this one down here, because you've got a top-heavy fraction now, you're going to have to put that back into a mixed number. And you should remember how to do that, because all we do is think how many of these bottom numbers go into the top number. How many 15s go into 20? Okay, well, I know that's only one whole one. And then what's left? How many are left? 5. 5. From 15 up to 20, there's 5 left. So it's 5 remainder out of 15. 15 is on the bottom because 15 is on the bottom of the original fraction. If you can't remember how to do that, go back into the video and have another go at it. The only other thing you could do here, because you've got 5 out of 15 as your little remainder, you could simplify that. Okay, how would you simplify it? We would put it into its simplest form. And again, we've done that already today. You need to just think of a number that goes into both 5 and 15. So I can divide both of these by 5. Okay, 5 divided by 5 is 1, and 15 divided by 5 is 3. Okay, so my final mixed number would be 1 whole 1 and 1/3. Okay, it still means the same thing as 1 whole 1 and 5 over 15. Okay, so when you're multiplying fractions, very easy to do. Just make sure that you are comfortable changing between improper fractions and mixed numbers. Okay, so why don't you have a go at this one? It's good practice then now. So pause the video, have a go, and then press play for the answer. Okay, if you've done that, remember what I just said. First things first, you've got to change this into an improper fraction. All right, so looking at that, you've got 1 2/5, And remember, all you've got to do is 1 times 5. So 1 times 5 is 5. And then we add the 2. 5 add 2 is 7. So it would be 7 over 5 because 5 is on the bottom of the fraction. So then what I end up with is 7 over 5 times by 3 over 5. Okay, because I've got 3 over 5 here. And like I said, once you've done that, it's very easy to multiply fractions together. You do 7 times 3, which is 21, and 5 times 5, which is 25. Okay, and you don't have to do anything with that because you can't actually put that into a mixed number because it's a normal, it's a proper fraction. Okay, the top number is smaller than the bottom. We also can't cancel it down because no numbers go into both 21 and 25. Okay, so hopefully that was nice and easy. Let's quickly look at a bit of division. This is also fairly straightforward. Right, why don't you pause the video and have a go, and then I'll go through the answer as well. Okay, so again, this one is straightforward, but if you have a mixed number version, again, you will have to turn it into an improper fraction. Now then, when we divide fractions, it's a really simple method. All we do is we write out 2 over 7, which is our first fraction. So we write out the first fraction. We then change the divide to a times, and we then flip over this second fraction. So instead of 3/5, it'll be 5 over 3. Okay, we flip it over. And then we just multiply across like we did before. 2 times 5 is 10, and 7 times 3 is 21. And you've done it because you can't cancel that down, and it's a proper fraction. So it's done. When you divide, you write out the first fraction, you switch the divide to a times, and you flip the second fraction. Okay, and then once you've done that, you just multiply them rather than divide. It's just easier. Okay? All right, why don't you pause the video and have a go at this one? Remember to turn that number into an improper fraction first. Okay, if you've had a go at that, first things first, let's turn 1 2/5 into an improper fraction, 1 times 5 is 5, and then we add the 2. Okay, 5 plus 2 is 7. So we would have 7 over 5, again because 5 is on the bottom. So we now have 7 over 5 divided by 4 over 9. So we just do our method for division now. We write out our first fraction, we turn the divide into a times, and we flip our second fraction. Okay, 9 over 4 instead. We then multiply across. Okay, 7 times 9 is 63, and 5 times 4 is 20. Okay, now we've done the multiplication, we've worked it out, but we now have an improper fraction. Okay, and because we've got an improper fraction, we need to turn that into a mixed number. And remember from earlier on, the way we do that is, if I put it down here, 63 over 20. How many of these 20s, how many whole ones can I fit into 63? Well, if I do my 20 times table, I can do 20, 40, 60. Okay, so I know 20s go into 60. All right, so I've got 3 whole ones. 3 times 20 is 60. I've got 3 whole ones, and then I've got this 3 left over. So 3 left over out of 20, because 20 is on the bottom, so it would also go on the bottom there. And you've done it. You've turned it into a mixed number. Okay, so just remember the simple methods for multiplying and dividing, but you also need to remind yourself of how to change improper fractions to mixed numbers as well. Okay. Okay, let's look at a few fraction problems then, and then we're about to finish. Okay, so looking at this question, if you'd like to have a go at this, please pause the video. This could come up on a calculator or a non-calculator paper. If it was on a non-calculator paper, you'd probably get quite a few marks for it because doing it without a calculator is a little bit long-winded. Okay, let me read the question. A school has 1,400 students. 740 students are boys. 3/5 of the boys and 1/4 of the girls study French. Work out the total number of students in school that study French. Now, I'm going to do all of this without a calculator just so that you can practice some of the methods that we've used in the previous lessons, such as subtraction, multiplication and division. This could come up on the calculator paper, in which case you wouldn't have to do all of that, but I think it would be good for you to practice it anyway. So if you are going to have a go at it, try and do it without a calculator and then press play for the explanation. Okay, so let's look at this carefully. We've got a school that has 1,400 students. 740 students are boys. We also need to know how many girls there are because it talks about girls in the question. So what I'm going to do first is I'm going to take 1,400 and I'm going to subtract 740. Okay, because that would give me how many girls there are. So remember, when we're subtracting, we're going to start at this end. 0 take away 0 is 0. Then here we've got 0 take away 4. Well, we can't do 0 take away 4. So we're going to take 1 from this 4 here. We're going to turn that into a 3. We're going to take a 10. And we're going to add the 10 to that 0. So that would make it 10 take away 4. 10 take away 4 is 6. And then here we've got 3 take away 7. Okay, well if I just took that 10 instead, it would be 13 take away 7. 13 take away 7 is 6. So I know I've got 660 girls. Okay, lovely. Now, the fraction part of my question is telling me that 3/5 of the boys study French. So 3/5 of the 740 boys. Okay. It then tells me that 1/4 of the girls, so 1/4 of 660 girls. Okay, so that's what I've got to work out first. Well, second. Now, 3/5 of 740, that means that I've got to do 740. I've got to divide it by the bottom number, remember? Divide by bottom. So divide by 5, and then I'm going to times it by the top. So let's divide by the bottom first. 740 divided by 5. Okay, so I'll give you some practice doing your bus stop method. How many 5s go into 7? That's 1. And we've got a remainder of 2 because we've got 7, not 5. So I can either put my remainder there to make it 24, or I can put my remainder down there and bring the 4 down. Okay? It's up to you. Now we'll say how many 5s go into 24. Well, 5 times 4 is 20, and 5 times 5 is 25. So 25 is a bit too big. So 5 times 4 is 20. So 4 5s go into 24, and you've got 4 left over. So I'm going to put 4 down there and bring down my 0. Okay, because I've got to use all the digits under my bus stop. How many 5s go into 40? Well, you should know that one. 5 times 8 is 40. Okay. So 740 divided by 5 is 148. So I've divided by the bottom. Then I need to times by the top. So I've actually got to do 148 times 3. So I'm going to write 148 times by 3. All right, because I've got to times by the top. So using the column method is quite easy when you've only got one digit here Okay, so we're just going to do everything on the top multiplied by 3. Okay, 8 times 3 is 24. So remember, we write our 4, but we carry the 10. So the 20 goes on the bottom, okay, to carry that over. We're then going to do 4 times 3, which is 12, but then we add the 2. Okay, so that's 14. So the 14 is 10 and 4. So 4 goes there, and we carry the 10. We then do 1 times 3, which is 3, add the 1, which is 4. So 444 boys study French. Okay. Let's move on to the girls then. It says a quarter of the girls study French. Now, you could sit and do 660 divided by 4. Okay, because remember we divide by the bottom number. All right. The other way you could do it is you can half 660 and then half it again, because a quarter is the same as halving it and halving it again. Now I'm going to show you the bus stop method because it will be really good for you to see it again. But if you half it and half it again, that will give you your answer as well. So how many 4s go into 6? That's 1 with a remainder of 2. Okay, because 4 up to 6 is 4 with a remainder of 2 gives you 6. We then bring down our next number. Let's put 6 there. Okay, and we say how many 4s go into 26. Okay, well, 4 times 5 is 20. And 4 times 6 is 24. Okay, so 6 times 4 is 24, so 6 will go there. Okay, and again there's another 2 remainder because I've actually got 26, not 24. And then I'll bring down my last 0 to go there. And then how many 4s go into 20? That's nice and easy, that's 5. So actually, if I did 660 and I divided it by the bottom, it gives us 165. Divide by the bottom. And I could times by the top, but the top's 1. So it just gives us the same answer anyway. Okay, 165. So we've done all of that without a calculator. It then says, work out the total number of students in the school that study French. So we just need to do 444, add 165. 4 add 5 is 9. 4 add 6 is 10. So we put the 0, carry the 1. 4 add 1 is 5, plus the 1 is 6. So altogether, 609 students study French. Okay, let's do another one. Okay, again, if you'd like to pause the video and have a go at this, then please do. I'll read the question. Charlotte's take-home pay is £930. She gives her mother a third of this and spends a further fifth on going out. What fraction of the £930 is left? Give your answer as a fraction in its simplest form. So pause the video and have a go and press play for the explanation. Okay, so when it comes to something like this, it looks like really complicated and long-winded. But really, what we need to do is think about how much of the fractions has she used up. Okay, so she's used a third. Let me just grab a pen. She's used a third on her mum, and then she used another fifth on going out. So she gave her mum a third, and then she used a fifth on going out. So why don't we add those two fractions together using our cross-multiply method in order to give us the total fraction that she has used to go out, okay? To actually spend. So we're going to cross-multiply, which means we multiply the two bottom numbers. We put our add at the top, and then 1 is on this side. So we put 1 there and we cross-multiply with 5. And then 1 is also on this side, so we put 1 there and we cross-multiply with 3. You should already know how to do this. Okay, we've already gone through this. So we then work out the answers. 3 times 5 on the bottom makes 15. Put my plus in. 1 times 5 is 5, and 1 times 3 is 3. We can add them together then now. 5 add 3 is 8 over 15. So 8 out of 15 is spent on her mum and going out. Okay. The question says, what fraction of the money is left? Okay. Okay, so because you've added them together and it tells you that 15 is on the bottom, I know that 15 out of 15 is the whole one. Okay. So if she spent 8 out of 15, all right, 15 take away 8 leaves you with 7. So one whole one, take away the 8, gives you 7. So 7 out of 15 is what's left. And that is what's left in its simplest form. So you could say something like 7 out of 15 of £930 is left. Okay? Okay, so we're just going to finish off with some understanding of decimals. So how to write a fraction as a decimal and vice versa. So when number is written in decimal form, a decimal point separates the whole number part from the part that represents the fraction. So I know we've already done this a little bit before, but if you look at this number says 6,714.238. So it's saying that you've got 6,714 whole ones, and then this is the part of a number, a fraction of a number, okay? Now, we're going to look at changing a fraction into a decimal, and in order to do that, you can divide the top number, the numerator, by the denominator, the bottom number. You can do this using a calculator or by short division. Okay, let's look at some examples. So, you've got certain fractions that you need to know the decimals for. I would recommend that you know a quarter, a third, a fifth, 2/5, 3/4, and a half. Okay. You could even learn 1/8, which is written just here. I'll show you that in a second. You must know these. You must know these off by heart because they'll probably come up on the non-calculator paper. And although you can use short division to work them out, it can be a bit tricky. So 1/4 is 25%, remember, but as a decimal it's 0.25. A third is 33.3%, or 0.33 as a decimal. A fifth is 0.2, or 20%. 2/5 then must be 0.4. 3/4 is 0.75, and a half is 0.5. An eighth is 0.125. Okay, so try and remember those. It's very important that you learn those by heart. You probably know them already anyway because you've probably done them a million times at school. Okay, I hope. Now, if you get a fraction that you don't know, okay, so like 1/7, maybe, okay, let's say 1/7, you don't know what that is as a decimal necessarily unless you've seen it before and remembered it. Now, in order to work out what that is, they would give you a calculator for something like this. It'd be on a calculator paper. And you would treat this line as a division because technically that's what it is. And you would do 1 divided by 7. Okay, and it would give you the answer. Now, if you've been given one of these over here and you don't know them, you can't remember them, what you can do is you can use short division. So you would say it's 2 divided by 5. And what you're saying is how many 5s can you fit into 2? Now, you can't put 5s into 2. So what we do is we say it's 0 point and we add a 0 to the 2. And we say how many 5s go into 20? Okay, 20 divided by 5 is 4. Okay, so you know then that 2/5 is the same as 0.4, which is also what I wrote here. Okay. 1/8 is like saying 1 divided by 8. Okay, how many 8s go into 1? Well, you can't do that, so you say it's 0 point and then add a 0. How many 8s into 10? 1. Okay, remainder 2. Okay, 8, 9, 10. 2 left. Add a 0, because it's a decimal now, so you can just continue to add the 0. How many 8s go into 20? Well, 2 8s are 16. And then 17, 18, 19, 20 means there's a 4 remainder. Add a 0. How many 8s go into 40? That's 5. So you're done. 0.125, which is what I wrote here. Okay? So if you're confident doing that, then it's fine. But these ones over here, I would learn them. Okay? Now, this only works nicely when you've got something called a terminating decimal. A terminating decimal is something that finishes. So your numbers finish. 0.4, 0.125. Okay? They finish. Once you've worked out what the decimal is, there's no recurring. Whereas if you look at a third, okay, if I was to do this with a third, okay, 1/3, it's 1 divided by 3. How many 3's go into 1? Well, we can't do that, so it's 0 point, and then we add a 0. How many 3's into 10? 3, 6, 9. Okay, we can only fit 3 in. It only goes up to 9. So there's 1 remainder. Add a 0. 3's into 10? 3. 1 remainder. Add a 0. How many 3's into 10? 3. That will keep going. Okay, which is why we write it like this, 0.33 with a dot at the top saying it's going to go on and on. Okay, so as I've just said, these examples are terminating decimals, and some other fractions give recurring decimals. These never stop, but sometimes have a repeating pattern. So, for example, a third we've just looked at, usually written as 0.3 with a little dot, or 0.33, doesn't really matter. Now, another example could be 5/11. If you typed in 5 divided by 11 on your calculator, you would end up with 0.454545, and it would keep going forever. So we can write that as 0.45, and we'd put a dot above both of the numbers to show that both of those numbers repeated themselves continually. Another example is 4/7. Again, if you typed in 4 divided by 7 on your calculator, you would end up with 0.571428, and then it repeats itself 571428 as it's written here. So what we would actually do is just put a dot above these first and last numbers, because it's only going to repeat itself again anyway, so we don't need to write it all out again. Okay. Like I say, you'd get a calculator for these ones, so don't panic. But please learn these ones up here by heart. Okay, so sometimes you will get a terminating decimal and you'll be asked to turn it into a fraction. So these ones that we've just looked at on this page, these ones just here, they're technically, they've got decimals that are terminating. They're not recurring, all right? So, however, you're not just going to get the ones that you know, you'll also get ones that you don't necessarily know, okay? So to change a terminating decimal into a fraction, and I'll explain this as I give some examples as well, we look at the number of digits after the decimal point. So, for example, 0.23, okay, let's look at that one. The digits after the decimal point will be the numerator, will be what goes on top. Now, the denominator, okay, so let's say if I had 0.2, that's only got one digit after the decimal point. Okay, so the top would be the 2, the bottom would be 10. So if there's only one number after the decimal point, the denominator will be 10. In this one, 0.23, there's 2 digits after the decimal point. So 23 will be the numerator and 100 will be the denominator. Okay, two zeros. And if there's 3 digits, that'll be the top number, but the bottom number will be 1,000. Okay? Now, that's the easiest way to do it, but then we would have to cancel down where we can. All right. Now, I could divide this all by 5 if I wanted to. I could say, well, it's 165 over 1,000, yes. But now I must cancel down where I can. This one says 2/10. Okay, fine, it's 2/10 because there's a 2 there, and I know it's only one digit, so I must put the 10 underneath. But then I need to cancel down. I need to put it in its simplest form. And I know I can divide them both by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5. So it's the same as a fifth. Okay. 165 over 1,000. Now, we can divide both of those by 5 because anything that ends in 5 or 0 can be divided by 5. Okay. So, I'm not going to do this as a long division method because I've gone through that enough times. 165 divided by 5 is 33, and 1,000 divided by 5 is 200. Okay, and we'll just have to leave it like that. Now, again, if you didn't have a calculator and you really wanted to work it out, I can quickly show you, I suppose. Okay, 165 divided by 5. How many 5s go into 16? Okay, well, let's write down some 5 times table just to make it easy for us. 1, 2, 3. That's the closest I can get, but 16 is the number we've got, so there's one remainder. I then bring down the 5. How many 5s in 15? 3. Okay, so you've cancelled it down. That's as far as you can go anyway, so you're done. All right, so just a quick recap of that. If you have a decimal with only one digit, you put it over 10. If you have a decimal with 2 digits, you put it over 100. If you have a decimal with 3 digits, you put it over 1,000. But then you must simplify. You must cancel down. Okay. If you had 0.2, okay, you should know that that's 1/5 anyway. You need to learn that. Okay. If you got 0.4, you should know that that's 2/5 anyway. If you got 0.25, you should know that's a quarter anyway. Okay. If you got 0.5, you should know that's a half. You must learn those ones that I put on the previous page. Okay, so here's some other examples then. So like I've just said, 0.24. 0.24 has got 2 digits, so we put it over 100. We then cancel down. We've divided by 2 here. Okay, 24 divided by 2 is 12. 100 divided by 2 is 50. I've then divided by 2 again. 12 divided by 2 is 6. And 50 divided by 2 is 25. That's as low as I can go. I can't go any lower because 6 and 25 don't have a common denominator. Now, another example, 0.355. Okay, this is a 3-digit decimal, so it goes over 1,000. Remember again, if it was just a 1-digit decimal, we'd put it over 10. But we'd have to cancel down. I can divide by 2 here. 3 over 5. Okay, so going back to the 3-digit decimal, we put it over 1,000, and then here I've just divided by 5 to give me the lowest number I can get, 71 over 200. Okay? Okay, the last thing we're going to look at is one more example of ordering decimals and a different way of doing it. So we've looked at ordering decimals in the first number week. So I just want to show you one other method for doing that. So another way of ordering these decimals is to give them all the same number of digits. Okay, so although we've got some that are obviously smaller than others, sometimes it's not always obvious to see. So I want to write them from smallest to biggest. Okay, so what I'm going to do is I'm going to look at the number with the largest amount of digits after the decimal point, and it's this one here. So what I'm going to do is, this has got 3 digits after the decimal. So I'm just going to add a 0 to everything so that they have 3 digits after the decimal. Okay, so that's now got 3 digits, that's now got 3 digits, that's now got 3 digits, and that's now got 3 digits. I'm going to write out my numbers, okay, so that I can see which are the biggest as I'm writing them down. Now, it's obvious, first of all, that, well, hopefully it is, that this 2.930 is our smallest number. Okay, I'm going to write that down there. 2.93. I'm not going to use the extra digit I've added on when I actually write my answer, but that is obviously the smallest number because it starts with a 2. We've then got loads of 5s. Okay, I'm just going to change my colour because I want to show you why this matters. So first of all, I've got all these 5s, but because they're all the same, 5 point, blah, 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 I'm going to look at this first column here to decide which one is my next smallest. So which one is my smallest 5? 5.2, 5.0, 5.7 or 5.7. So 5.2 is like saying £5.20 and 5.0 is just like saying £5. So this one is going to be my next smallest, 5.041. Okay, so let's cross that one out, we've used it, cross that one out, we've used it. Now then we've got 5.2, okay, and then I've got 5.7 and 5.7. So 5.2 is our next one, 5.29, okay, because it's a 2. Okay, so this was 5.0 and this is 5.2, so it's got to be bigger, regardless of these numbers. Okay, so then all I'm left with is 5.700 and 5.710. Okay, so I know that looking at this column isn't going to help me because they're both the same. So now I've got to go to the next column. And if I look at the next column, it's actually this one that's a bit bigger. Okay, because it's got a 1, whereas this one's got, the top one's got a 0. So our next smallest is 5.7, okay, which was this one, and then 5.71. So we've now written them from smallest to biggest, okay? And I just wanted to show you that one more time. Okay, so I hope you feel confident ordering, adding, subtracting and comparing amounts or quantities using proper and improper fractions and mixed numbers, as well as expressing one number as a fraction of another. So good luck on your assignment and I look forward to seeing how you do.